Okay, how are you doing, everyone? And this is the just a reading for the exploratory data analysis. While we was pre-processing the data, I do some stages in Data Studio. So the first page is regarding the data while it is not very processed. So it was a row based, not a columnar. So this is an estimation about that. This the main data when it's row based. So as you can see that the number of heart rate is counted in the ones that who charted. So you will see that this by seeing this there is a lot of uncharted data, and also there is a lot of missing part. So in most cases that we don't have all information, and to be able to think about this, can we predict this value? Can we make a model that are using sklearn and using imputation, just showing that the values for heart rate and temperature, and as you can see that if you train the model, or if you're doing any sklearn imputator, like iterative one or any other, it's can be predicted. So the data can be predicted, or you just can fill it with the missing can be filled with the forward or backward method. But just that you have to know that you have to train it on the full data and not to exclude things. So the model can have a good look about the features, and you know that there is majority of the data in a specific place. So for temperature, as you can see in here, that this very tiny difference between them, while in repository rate, it's there is a differences, and there is a huge gap between this value and others. Now in this page, in just loaded. Okay, because the data is large, internet is so bad. Let me just pause the video while it's loading. So I'm just to try to, well, this need to do more pre-processing on the data to make it as a time series based. But I'm seeing that from reading the heart rate and the blood pressure and charting them by the time, that if building a model based on time series can give a better work, better accuracy, because there is a relation between the old read and the previous read and the new one. While on the other page, I'm just trying to just it's open so we can read this. Well, on this page, I'm just showing you that you can clearly see that not all the hours is charted, so you don't have for each patient a full 24-hour recording for um, its viral science. So there is a majority of time there is a charting, and there is other time that is no charting at all. While if you want to get deeper into understanding the data, um, actually this need to be more process the data, but in general it is very imbalanced data set. While the case group is so much less than the control group, and by this you could clearly see that you must work on a model and put a weighted loss. So or try to make it to train on a float, and to do, let's say that, taking some from control group, train it with the case group, taking different float with a different model, train it with the same case, and so on. So trying to make balance between imbalance. This is another suggestion. Now, to see that if the data can be separated by feature, if the feature is clearly separable from each other, we have the case group and the control group. This y-axis is the same value because in the data itself, this has to be changed to categorical. So there has to be 1 and 0 or 1 and 2, whatever you like. But since that it is not, I'm just taking the data and showing it, we can understand that there is such kind of that the majority of those who patient in case group has a different heart rate than those who in control group. While using other features, as you can see that here in mean value temperature, they are equal and they put it in the same. So I flipping the y and x axes, so you can see the separation that the both are there is so little tiny difference between them temperature. So 37.02, 37 point. This is the average. So the temperature is not a very good judgment between two, but it can help or not. You should explore it in the model. While the heart rate is something that's crucial. And the same for the other. And as you can see, there is no much differences. So maybe here there is a 1 point gap, while in here there is 3 point gap. So this two feature can have some separation. Okay, so this is the main systolic blood pressure and main value respiratory rate. Moving to the how much that hours between cardiac arrest happen and record count. So this is the time differences now when it's negative, because the use of big query time differences. So the negative is that this has happened and that there is a cardiac arrest happen and it's passed. So when working on minus, that is mean it's already the event has been done, and this is a new chart. So this, if you want to work on it, you need to exclude this negative or reschedule it as the next stage if there is a new case for this one. And as you can see that there is so little amount of data available, so this need a careful working on training models. While here I'm just showing you that after this data has been processed in the Clominer, that this the charted, hourly charted by case and control group by each group, and this by subject ID, so you can know the how much you have actually, how much patient you have, because for the same patient there is many charting and many days that is under monitoring. Now moving next is that just to understand that to see that the gap between the value. So we are taking only the case group, the credit arrest. So when the arrest is happen times 0, as you can see, this is the heart rate reading, the mean value for this heart rate, the respiratory rate, as it's clearly showing that the differences between these value can give you a clear look that by intuition if this can be used as a good judgment alone, and I don't see it can be used alone. It's need to be taking in consideration as a time relation. So maybe you take a window for each user as a 5 hours. So you take this previous, either that you take in the current reading and take the standard deviation and the mean for the past 5 hours for each read and add it as a new columns, or you're working on it as a time series based. So each patient is about related time series based event, and there is the final output. So this is as an event will fit one by one as time plus time t, x time t plus 1, x time t plus 2, x time t plus 3, x time t plus 4, and this is the current. And this will be fed to the LSTM and will help build the relation between the previous read. If you don't want to work it as a time series, you need to take the window and take its standard deviation and the mean for each of this read for the previous, let's say, past 5 hours, and put it as a new column. And this will help you, by the way, if there is a lot of missing data, because this you will take a standard deviation and the mean, even though you will have for some patient only 3 out of 5 hours, but will be enough and good to get a judgment. Yeah, this is all about what I was seeing from the data. Simple exploratory data analysis. I don't want to get deeper. I just want to take some overview so for could help us in feature engineering. Also, I am not very available on this time, so was want to help in modeling and feature engineering. I give some suggestion here, but there is a lot of tasks to be done and a lot of job, and I grateful that we already finished my task one team, the data team. We already completing everything, and happy that everything has been done, and so far that there is good progress in the project. Yeah, see you.